What'd you say?
We're recording.
I don't see your video thing on there. It's just
Hello, everyone.
hey guys, I'm Annabeth Hrdlicka.
I'm Masheka.
And this is chapter 2, sets and whole numbers, number 3, and chapter 3, numeration and computations. And we're gonna do some questions about that today.
This is our module 2 presentation.
Yes, ma'am. Module.
Okay. The first question is to construct a 3-loop Venn diagram and show all 8 elements of U. It then lists the elements of the sets, and it shows us what we're solving for, which are these, and then it gives us these. So first, to solve this, we need to know what a 3-loop Venn diagram is. A 3-loop Venn diagram shows all possibilities of a question. And to solve this, we need to know our symbols. So our symbols are a U and an upside down U. The U stands for union, and the upside down U stands for intersection. And Annabeth, I do have a question. Why are the symbols so important in this question?
Okay, so the symbols are everything for this question. So not only do you need the symbols to set up the diagram, but you also can't even solve without having the symbols. So the symbols pretty much teach you what to do, and yeah, you need the symbols to do it all.
Okay, that makes sense.
And I have a question for you as well. So what exactly is a union?
A union, well, I'll see a union as or. So the simple way to put it is a union is all possibilities for our 2 sets. These are our sets. So you see how union combine these? So we need to see all the possible letters for these sets, like B and C. So that's basically what union is. Okay?
Okay, thank you. That makes sense.
Problem? So this is our problem. Now, my second question for this problem is, how will you know what to put, where to put the letters? Because it gives us our letters, but how do you know how to put them in a diagram?
Okay, so to know where to put the letters, you have to look at what letters that the A, B, and C, which you see, the main letters, which ones they're equal to, and see which ones they both have. So you see at the top, it all says A is equal to B, C, D, G, H, B is equal to D, F, H, and C is equal to D, G, H. And then to make the diagram, as you can see, you got to see which ones both have. So, for example, A and B will both have D and H. So yeah, A and B, C in the middle, D and H.
Okay, you explained that perfectly. Thank you. Now,
Thank you.
we're solving for these. So, like I said, the symbols are important. So we're looking for B and or C. So all possibilities for B or C. So that's our first question. What goes in B or C? So all the possible possibilities that can go, which is F, D, H, G. And then our second is we'll go in A and B. So only what A and B share. So A and B share nothing by themselves, but A, B, and C all share D and H. That will go for being A and B. And then you'll continue on until number 5 like that. Now number 5, a line above the A means everything except A. So everything in the A, which is B, C, G, D, H, will not be able to go into the answer, but A, N, E, and F will be able to. Now I do have a question for you, Annabeth. Why is A and E out of the diagram?
Okay, so as you can see, A and E are not in the diagram, unlike all the other ones. And this is because the A, B, and C are not equal to A or E. So A or E cannot fit into any of the diagram at all. That's why it has to be on the outside. So as you can look up there, A equals B, C, D, G, H, no A or E. Same with B, DFH, no A or E. Same with C, DGH. So it has to be on the outside.
Okay. And that leads us to our answer. And then it'll just continue this. And then you have A or B and C. So what B and C shares, which is D and H, or A, which is B, C, D, H, D. And that's how you solve that problem.
Okay, cool. Awesome.
Now this one, they want us to construct a Venn diagram of 12 shapes and basically show see what the letters, sorry, I had to move this. What the letters C, H, T equals circle, hexagonal, triangle, and S, L, R, B equals small, large, red, and blue. And we have our symbols, and we had to see what we have to find in our diagram. So I have a question for you, Annabeth. It says
Okay.
it's a Venn diagram. So we will not be able to use our three-loop Venn diagram because it's the diagram we're using. So why won't you be able to use a three-loop Venn diagram? Instead, you have to use that one.
Okay, so for this one, a lot of them you can use a three-loop diagram, but for this one you cannot because a three-loop diagram would not work for this because of the way the question's set up. So you see the figure, it's like all spread out and stuff. So if you were to put two more loops in there, the other shapes would just not be comfortably and it just would look weird, and just for this specific question it cannot work. But most of the time it will, but you just got to pay attention and just see how it looks in the end. This one would not work if the shapes won't fit. So
even though it's a Venn diagram, it don't have to be a three-loop Venn diagram. Thank you.
of course. For
So,
this next slide, I have a question.
oh, okay.
So you see the example. So why would a Venn diagram help someone solve this problem?
It helps to keep track of it because they give us different letters, which is equal to different things up here, as you can see up here. So it'll be best to keep the Venn diagram up here to see what everything equals to. So you'll know exactly like what to look for. So say you're looking for a small hexagonal shape, you'll have your hexagonal shape and you know how many numbers of the hexagonal shape it is. So it'll be easy to have the diagram drawn out right here. The diagram, that's why it'll be good to use a diagram. It's basically to keep track of everything that was given to you.
Thank you. That makes perfect sense.
To solve this, you'll basically do what you did on the last problem, which is L and H. So what is large and hexagonal? So you'll have your large hexagonal. Color doesn't matter because it didn't give us a color. And then, like always, C or H, so circle or hexagonal. Everything but triangles, basically. And then so on, so on. So T and red, so triangle that is red, and circle that are small and red because they N equals small and red. So these are the answers for this question. Let's go to the next.
Okay. Thank you.
Our next question is a number system. We have a number system, 1 through 10, but our other old systems, like from ancient times, they had pictures and letters. So basically, we're just solving for old number systems, how they used to solve it. So let's go to this one. The first question is in Egyptian. Oops, sorry. Why is it moving?
Oh, no, it's okay.
Just keep moving. Sorry. So the first is Egyptian number system. So we just look at the picture, what it represents, and then we multiply by how many it has. So 10,000 times 3, and then so on, so on. 5 times 10, because it's the 5 and 10. And that'll be our answer. And then we have a Roman numeral system.
Okay, cool.
I do have a question for you on a Roman numeral system, Annabeth. My question is, we see M, CM. So M is 1,000, but then we see CM. So my question is, how will you solve for CM basically? Because
So to
normally,
solve for
I'm sorry.
I'm sorry. No, you keep going. It's okay.
I was saying, normally you you just add everything like you did with the Egyptian number system. So why the CM? How do you use CM? Because they're different letters.
Okay, so for the Roman numeration system, this one is just like their rule is you have to subtract the right from the left, and that's how you know. So you see, MCM, you gotta subtract the right from the left, and that's just the rule. So that's just something you have to remember, just like our normal math, well, normal for us, our standard for today in America and all across the world has rules. And just like that, it's gonna have rules. Sometimes it doesn't really, we don't really know why, it's just how it works. And without the rule, it wouldn't work well, it wouldn't end up working.
Okay. So M equals 1,000 is CM. So we have M is 1,000 and C equals 100. So it'll be 1,000 minus 100, and that'll give us 900. So that's how we solve the number system, and then we just continue. And that makes sense. Thank you, Annabeth. That was very informative. And then we have our last answer. That was very good. You explained that very well.
Thank you. Okay, so for this next slide, I have a question for you. So this is the Babylonian numeration system, and my question about this one is, how many shapes / symbols does the whole Babylonian number system have?
Well, after looking up the Babylonian number system, I only seen two shapes, which makes it the easiest number system to solve for. Uh, it only two shapes, which is basically a 1 equal to an upside down triangle. Then a 10 is a boomerang shape, so 1 and a 10. So it's actually very easy, and they only have two to answer your question. They only have two.
Okay, thank you. That's cool. Only two. This makes it simple.
So we just multiply 4 times 10 and 1 times 1, which is 41.
Cool. That one's simple.
And now our last number system, which is the Mayan number system.
Okay, so I have a question about this one for you too. So this one is obviously has a lot more things you have to look into. So my question is, how overall do you use the Mayan number system?
Okay, unlike our other number systems, this one you have to multiply the number it gives you from the letters or I guess pictures you would call it, and then you have to multiply by the point value system. So there goes the point value system right here. So you go top to bottom. So the top is the fourth place, the bottom is the first place. First number system, fourth digit, and the top is the fourth. So you'll look at here, it says 5 for that. So 5 times the fourth place, which is 7,200. And then you do it, keep going, which is 6 times 360, and keep going down. Then you just add them all together like the regular number system.
Okay, cool. Thank you. That one's a lot more hard, but I do prefer the 2 per 1 for sure.
Okay,
Okay, so for this one,
oh, sorry.
For this one, so it's lattice multiplication. So you have to use a box, and my question for you is, how do you know which numbers go in each row for the box?
Well, to see what number goes in the row, you use the top. What goes on the top is the first number, and what goes on the right will be the second number. So 28 will go to the top, and 32 will go to the right. This is because of questions like CD. This have 4 digits. So the top will have 4 boxes, but this has 3 digits. So this will go to the right will have only 3 boxes. So that's why it's very important for the top number to go to the first one. The first number to go to the top, and the second to go to the right. And here,
Okay, thank you. That makes perfect sense. Oh, good example.
Okay, like I said before, the top, first number will go to the top, the second will go to the right, and you just keep solving. So 3 times 8 will give us 24. 2 times 3 will give us 6, and so on. And then you'll just add diagonally, and then it'll give you your answer, which is 896. And that'll be your answer.
Cool. Thank you.
And you just keep solving like you did the last one, which is 3 times 6, 7 times 6. And it'll just keep giving us. Now, I do have a question. You're supposed to add diagonally, of course. Now, say this one, you add this one, you get 14. The 4 will go to the bottom, and the 1 will go to the next row. Why would you move the 1 to the next row? Why would the first number go to the next row? That's my question for you.
Okay, so you have to move the 1 to the next row because the number is too large to fully fit on the outside of the square. So the rule is that if it's larger than 9, so if it becomes in the tens digits, then you have to move it. So that's why you see 8 on the side, that's fine, but then down here when it comes to 14, you leave the 4 and then put the 1 up there. So yeah, it's just a rule. Larger than 9 can't be there. Too large.
You explained that better than I ever could. That was really good. Thank you. And you'll
Queen. Damn, that's a big number.
And of course, you just do the next questions like this and add diagonally.
Thing with the number, you gotta move up.
And oh, okay. Sorry, I was just getting all the answers. You just basically just solve it like you do the others.
No, it's all
So I'm
good.
just trying to get out the way. Now, our last question is demonstrate the rounding from the exact to the
a good method if you don't have a calculator, especially. Because I know I couldn't do that in my head.
Yeah, I
and long division would take a year. Next question.
So this one you have to estimate and then round. So you'll have to use, please excuse my dear Aunt Sally, to solve this problem. Now I do have a question for you. To solve this,
okay.
You'll have to solve this the correct way. You'll have to solve the numerator and the denominator. Well, we have to solve those first before you get your exact answer.
Okay, so you have to solve those first because it says to do that in the order of operations. And if you don't use the order of operations, you will always be wrong. That's just, like I said before, it's just a rule of math. You have to use it or your answer will be completely off. It's a rookie mistake, but it's very important. You always have to use it. And as you can see, also adding is a part of that. So you got to add 2. So you do that. And then on the bottom, it's already put it together. So yeah, you got to do the numerator and the denominator first before you do anything. Because if not, it'll throw everything off and it's impossible to get the right answer if you don't listen to the PIMDAS.
That's perfect. Again.
Thank you.
So you have to just add this and then you'll have to divide this because it's last. That's good. Thank you.
Of course.
So that your exact answer would be that. And now you have to solve for the estimate. Do you have a question for me on?
I have a question for you.
Oh, sorry.
Yes, ma'am. So for this one, we have the estimated and the exact answer. And my question for you is, when do you know when to round up and when do you know when to round down?
Well, that's the rule of math, like you've been saying through this whole presentation. So the rule of rounding is that if it's greater than 4, you have to round up, and if it's greater than, if it's less than 4 or less, you round down. And to round, you have to look at the 10 digits. So if we look at the 10 digits, sorry, here, we see 883. The 8 would be the 10 digit. So since it's an 8, we have to round this up to 900, which is shown right here. And then this is a 6, so this will have to run up to 500. And this is a 3, so it'll round down to 100. And this is our estimated problem right here. And then we solve like we
Okay,
did
that
the
makes.
first one.
Okay, thank you. That makes total sense.
Thank you. And
Of
then
course.
you just solve, and that's it. And again, you just, to solve this problem, you just, of course, like you pointed out, you do the numerator first, then the, sorry, I get tongue tied on that word, denominator, and then you use the other operation. So you solve it first, and then you solve the problem together. So it will not make sense if you, what happens if you end up not solving the problems first, the numerator and the denominator first?
Well, everything will mess up, like we were saying. Everything will. It just won't work in the end. Like I said, the rules of math.
Okay, thank you. And of
You
course,
need to
you just,
follow the order of operations always. You cannot make up your own rules, or you will be left very upset and confused.
so basically you'll just get a wrong answer every time.
Yeah, so that's like the main rule of math, pretty much.
Okay, and now let's go to the last question.
Okay, great.
Okay, so this, we're using different bases. So we just have to solve using different bases, and the bases we have are 5 and 6. Do you have a question for me on this one or no?
So for this one, why is 10 the standard base always?
10 is the standard base because it is what we're used to. So we're used to if a number, like you said, like you pointed out in the multiplication, if it's greater than 9, it'll go to the other row. That's what we're used to. So basically, the base of 5 is if it's greater than 4, it'll go to the next row. So we're used to the base of 10 because it's just what we're used to. So if it's greater than 9, the 0 will go down and the 1 will go up. And just like you explained on the multiplication problem.
Okay, thank you. That makes perfect.
We just
Thank
have
you.
questions and how to solve it. So like 2, 2, 3. And then it's greater than 5, so the 1 will go up. And then you just add the next row, which is 1, 7. It's 7, but the 1 will go up and 2 will go down. So 5 go into 7 one time. Now I do have a question for you, and that is,
Okay.
why do you bring down a 5? Well, how do you know?
What was your question?
How do you know when to use the base of 5 or 6?
Okay, so you know when to use the base because it will tell you if your base is not 10 because 10's the basic one or the standard one. So it'll always say 10. Like, I mean, it will never say 10. Well, most likely it won't because that's like the assumed base is 10. That's the standard. So if it's not going to be 10, then it's going to tell you because it's not the standard. So you should assume it's 10 unless it doesn't tell you pretty much.
So like this one, you have the base of 5, and then you use the base of 6.
Because 10 is always going to.
Thank you. And this is, you just solve like the regular.
Of course.
And I guess that's it. That's our answer. Thank you, and have a nice day.
Hey. Yes, thank you guys for watching. I hope everyone enjoyed and I hope everyone understood well.
Yeah, can't wait to see you next time.